Hello, I have taken this peculiar heading as Mystery of Radioactivity because I still feel that it is not completely understood. People are trying to explain it with some other examples. In this detail, I'll discuss all these things. Please give your opinion after watching this and then give some other concept if you want to give it. Yes, as you know, whenever somebody says radioactivity, then suddenly we will get this particular diagram, that is half-life period. First of all, it works when there is large number of atoms, and therefore I'm taking these figures. Let us assume that it is not just 1024 atoms, say 1024 kg of the material, so that it will be quite large. So what happens if the half-life period is say 1 second? For convenience, I have taken this interval as 1 second, say. So 1024 kg will become 512 kg, and the remaining half is converted into some other element or next element. Again, after another second, the 512 kg will become 256 kg of the original material, and remaining 256 kgs will be converted into next material, and so on. So as we know that we are going to understand everything with another example, we will try to understand this, or normally people will try to understand this with what is called as probability or tossing a coin. So we will just think of that one in the next slide. Before tossing the coin, let us first see the atom. Normal atom will think that it is somewhat like this. Let it be simple high school logic. Anyway, the nucleus is here, and this particular nucleus is going to split during the radioactivity and becomes a simpler element or whatever it is, and therefore the atom structure we are seeing, and we are now equating it to what is called as tossing a coin. Yes, when we toss a coin like this, there are only two options. Either it will be head up or tail up. And this is what we are equating it to radioactivity. That means we are thinking that that is also a two-step process. That means one element will be there and somebody will toss it, nature will toss it, and some atoms will be same and some other atoms will become the next atom, like tossing several coins, which I am going to show it in the next slide. Yes, here I have done several circuits, a different analogy to make it equivalent to a radioactive state. That means, like atoms, there are several coins. Some are showing head up, some are showing tail up. But assume that we are arranging it in such a way that all are having head up. Also, once we toss it, suppose there are 1,000 coins, we are likely to assume approximately 500 will fall down with head up, and the other 500 will fall down with tail up normally, approximately. But when we toss it again, then it will be flipped again. Just to avoid it and make it equivalent to a radioactive state, what I assume here is we will initially make all the heads up, and then we will coat the gum on all the heads, so that when we do the first tossing, half of them will flip and heads down will be there, tails up, and they will stick to the table. And the next tossing, it will not jump at all. So there are 1024 coins if you assume. After the first toss, 512 coins will show tail up and stick to the table. The remaining 512 will fall down, tail down, so that it will not stick because the gum is on the head side. And once again, when we toss it, then again half of 512 will stick to the table, and so on. So with this complicated arrangement, what I have done is, it is almost representing a nuclear reaction. There it may not be a step process like this. Continuously it will be happening several milliseconds. It will take between one atom and another atom. Anyway, rough estimation, or what is called probability method, is this particular one. Because in the general case, what people will do is, once they toss, they will take out all those heads up coins away and toss it again. Instead of that, this particular method is more suitable. Anyway, we are now analyzing this particular process of tossing, how it is equivalent to a radioactivity itself. Probability is the word that we are going to use to explain such things. See, remember, whenever a coin is tossed, it is likely that it is going to show head up or tail up, and that probability again is 50%. That means if you toss it 100 times, it is likely to show head up 50 times and tail up another 50 times. Not exactly, but if you increase the number, it will be 50%. It approaches to 50%. Further, we will not reason it out because we will stick to this word probability. And the logic for this is, head showing up and tail showing up are equally likely. Another term which is not so perfect, equally likely. So in the next one, I'll just tell you about that equally likely. Take a coin. If you apply calculated force while tossing, when there is head up, we can design an accurate machine in a controlled environment of air, etc., etc. We can make again the head up or tail up, depending upon this calculated force, weight of the coin, etc., etc. That means it is not equally likely. Since in the hand we do not know how to control the exact force, it will fall head up and tail up at different times because of the variation in force, and that variable force is also not likely to be equal, and therefore approximately we are getting 50 and 50%. But if I can make a machine when head up is to be shown 1,000 times, if I toss, I can make it to show head up all the 1,000 times. That means we can control the output in a coin. So what people are saying is, in a coin anyway we can control if it is very accurate force, but in atomic level we can't control. Let us not control, but the nature can apply forces which are small enough for different atoms to behave in a different way. And therefore, what I conclude is, no two things are equally likely in the world. Look at this coin itself. When it is equally likely, you have to put both head and tail up or both head and tail down. How is it possible? When we say that head is up and tail is down, it is not equally likely. It is unequal now itself. Yes, my another approximation, of course, is to keep the coin like this. That means neither head up nor tail up. Then allow it to fall down. then it will jump several times and fall either head up or tail up. Then also it is not very equally likely, but somewhat likely. That is why every atom, every electron, every neutron, every proton, or whatever may be the particle, will be at different places inside the nucleus and vibrating in a different phase, and therefore they are not equally likely. No two atoms are equally likely because of their different in position and different in vibration characteristics. So they are not equally likely, and therefore it is not just sufficient to apply probability. It is very important to know what is actually happening inside the atom. What exactly keeps the time? Now, instead of a probability, we'll now assume that there are several clocks like this, and at say 12 o'clock or somewhere it rings. Each clock will give an alarm, a ring. Only thing is, they are all set for different initial times. Therefore, some will ring after 1 minute, some other will after 2 minutes, and so on. We'll apply this analogy to radioactivity. What will happen when we apply clock analogy to a radioactivity? That is just because if there is nothing or sensitivity to time element is not there, then even that half-life period should vanish. It should become random, no half-life period. Suddenly some thousand atoms will react, and after 1 year nothing will react. Something like that should happen. Since it is maintaining a particular rule of half-life period, there must be something which is sensing time, and therefore we are assuming not tossing a coin, but several atoms representing several clocks ringing at several different times, and therefore we are seeing radioactivity. We'll apply this analogy and see what will happen. Just for convenience, we'll just take some 8 and assume that 1 second is the half-life period. After 1 second or within 1 second, maybe some variations, within 1 second, after the end of 1 second, four of them will ring. So that means equivalent to converting it to a different element. Afterwards, it will not ring. In the remaining four, after another 1 second, two of them will ring. In the remaining two, after another 1 second, one will ring. Of course, this I have assumed it to be ringing after 4 seconds, but since there is only one, probability will not work or whatever it is. Assume that it will also ring, and therefore it follows the same curve like that. Half-life period like curve. But what exactly is different in each of these class? In one of the clock, say the initial time is different, again different, so that the total time difference within this was 1 minute and at the 1 second, and at the end of 1 second somehow all these clocks were ringing, and that was the end of this. Similarly, at the end of 2 seconds, two more, and so on. Yes, now I have arranged these clocks in the sense that suppose there are 1024 clocks, 512 will ring and go away after the first second, remaining 256 after second. Very clearly, if the difference is linear, say this is having 1 millisecond, next clock is having another millisecond from 12 o'clock, etc. If there is a linear difference, it won't work. There must be a non-linear difference because the equation is exponential. So if this is having 1 millisecond less, next one is having some other milliseconds, etc., then only it will work or it will follow the half-life period. So in clocks there can be different settings, etc., but how one atom is different from the other atom at the atomic level? What is the difference? There can be a structural difference or whatever it is, but why? So only reason that we can give is initial starting time, or when the atom is created, this atom started first, and after several hours or minutes or whatever it is, the second atom came or generated by some other element. So this way we can say that this is ahead in time compared to this. So how far that logic works? Of course, that should also be non-linear ahead of time for one atom to another atom to another atom. Anyway, we'll just see how this particular thing works, or how to get these atoms generated at the same time so that we can analyze. That makes us to consider two-stage decay of elements. That means from one element, say uranium, to next element, thorium. So what is the advantage? Initial uranium, which was there from several lakh years ago, and therefore atoms are different. Now we'll forget this initial. We'll think of the generated thorium from the fresh uranium, or whatever uranium pieces that we have taken where there was no thorium at all. We got some 512 atoms of thorium. So all these 512 were almost generated within a second, if the half-life period is so much. But then also that will follow the half-life period, which is different from this half-life period. So when it is generated, something else happened, and therefore the timings were readjusted, and therefore it is showing some other half-life period. But remember, there will be the third one from this second one, which is showing again the third type of half-life period. Also, there can be a stable element which is not shown here, that is not showing any half-life period at all or infinity. How can we explain this? Again, we can't analyze what exactly is different from one atom to another atom, because we are getting almost all the atoms within the half-life period of the first element. Suppose the half-life period of first element is, say, some 10 minutes. All the second set of atoms are generated within the 10 minutes, but they are having a different half-life period compared to the first one. Again, it boils down to two very important things, that how one atom is different from the other atom. Even when it is created, how can it be within 10 minutes become such an atom that which can decay after a million years compared to this? Anyway, to know that time is happening, there must be some clockwork mechanism inside each atom, otherwise it will be insensitive to time. How do we know that it is sensitive to time? Of course, that is extremely simple. By theory of relativity, if one atom is moving at a very high speed, and then definitely it will move like this, and the radioactivity will be different because of this high speed movement, which is comparable to the speed of light. That has been proved. So when an atom is moving at a very high speed, time is dilated. That means it is sensing time. So what exactly is that sensing time? That is not just 1 or 2 seconds. If the half-life period itself is several years, like 10 power 6 years, then some atoms are sensing 10 power 12 years. How is it possible? That is a big mystery. It is not simply the probability. There must be a definite timekeeping element which we have to understand by a deeper science. Of course, why should we understand? Because of this, we want to observe nature, try to understand, because we want to control it. Suppose there is something happening, we'll observe it, and then understand it, apply the logic, and control it to according to our desire. With this in purpose, we'll try to understand. But in certain concepts, a majority of the things like deep astronomy, etc., out of curiosity, many will try to understand. That is also there. Anyway, this understanding is a process. We can't simply stop asking why at all in science. Just because we can't understand, there is no need that we should stop asking why or how. When you stop, that is the end of science. Science is continuously trying to know more and more and trying to understand, etc., etc. That is endless. One of the fundamental method of understanding in science is we will understand almost everything from other examples. But unfortunately for radioactivity, there is no other example. It is only one in that kind. When we analyze it for coins, it will fail. When we analyze it for clocks also, it will fail. It is something other than all these things which we have to see and understand, probably without example, or that itself is an example. Extremely difficult to visualize what it means. Are micro and macro sciences different? This is another fundamental question that we will get, because we can understand all the planet's big elements and not the small atoms. And in that context, quantum mechanics came into picture, but still they are trying to combine macro also into that one. And there cannot be different sciences, there can be different rules. Science itself cannot be different, because all these micro will become macro because of their numbers and arrangement. Finally, is it a mystery? Still, it is a mystery. According to me, we have to do something else. So many more experiments are thinking to have a deeper understanding of what actually is happening inside an atom or inside a radioactive atom, so that the clockwork like activities are resulting somehow in the form of half-life period, which are different for different radioactive elements, and so on. Thank you for watching. Please give your opinions in the form of comments or whatever it is. Thank you very much.